Thank you. Y'all are able to hear me, I'm guessing. I have one of those colds that's lasting forever, so just in case I have to stop speaking halfway through, I've just put a link to the publication that I'm going to be talking about at the end of my 10 minutes. If I cut out, just go read a really great paper for a couple minutes and you'll see some of the results that I wasn't able to speak through. But everybody cross your fingers with me. I'm going to talk about citizen science at my program, tracking some impacts of us on the marine environment. And on the next slide, I will tell you a little bit about my program. I'm with COASST, with the Coastal Observation and Seabird Survey Team. This is a citizen science program where folks walk beaches, not just within the Pacific Northwest, Washington, Oregon, but also in Northern California and up in Alaska. We partner with a number of additional citizen science organizations like ourselves to cover even more ground in BC and in Southern and Central California. And I'm going to tell you a little bit about some of the data that we collect today in these programs. Next slide. So in my program, we train participants in classrooms and on the beach locally in their communities to conduct monthly observations of their beaches. The program that I'm talking about today is our beached bird monitoring program. So folks go out and learn to identify beached marine birds on site with a custom field guide, and they send in their data once a month. So they're reporting monthly on the same site. They tell us if they see a bunch of birds, they tell us what species those are. They also tell us if they see no birds. And this helps us to do a real-time calculation of sort of baseline data, what's going on in the marine ecosystem based on which birds are washing in from the marine environment onto shorelines where they're easy to observe for people like us. Next slide. What this looks like if you are a coaster, which often there are some in the audience here, you will go out to a beach. You'll spend about 5 hours conducting a very specific set of protocols to survey for these birds. You'll be collecting measurement information and writing down some of the metrics that you're using to identify the bird. And then we're submitting all of that with photographs of the beach bird carcasses that are all independently verified within house here by staff at the University of Washington. Next slide. Those data, when they all get put together, are, oh boy, it's an animated slide. I apologize. 3 more clicks forward, I bet. Perfect, thank you. Our data comes together usually in a term that we call encounter rate, where we add up the number of carcasses that have been encountered within a known stretch of beach. We standardize to 1 kilometer of beach. And then we track how that changes over time in different seasons as well as over years. And one of the things that we notice as we have calculated this baseline over the last quarter century, over the last 25 years, is that we see a cyclic pattern in some of the species where we have a pulse of a bunch of birds ending up on beaches just after the breeding season ends, where a lot of birds have expended all their energy on rearing chicks. Parents in the audience, you know what I'm talking about. We see more birds on beaches because they're nesting close to shore and they're dying close to shore right after the breeding season. In the middle of the winter, we'll also see peaks in birds on our beaches just due to big storms that even the best offshore birds sometimes can't survive if they're just living right on the edge. And finally, we see a little peak sometimes in our baseline calculations in the springtime when birds are undergoing migration, which can also be stressful biologically. Next slide. Now, when you zoom out over a long time scale, you can see this yellow heartbeat happening in the number of birds that we're finding in each month of each year in this particular region. We sort of see the same pattern year over year over year. In some years, we see bigger winter kill. Some years, we see bigger post-breeding mortality, which might mean actually that the seabirds had a really good breeding year. And so we're seeing more birds die because so many of them returned and bred. But over time, we like to call this our heartbeat signal. We know, just like if you're in the hospital looking at your heart rate monitor, we know what it sort of should look like because we've been looking at these beaches for so many years with so many eyes and in so many locations. Next slide. Now, these baseline data we have used to do a number of things over the years, and one of them is to track metrics of who suffers the most when there's an oil spill offshore. We might also track in the future impacts of offshore wind farms on marine seabirds because we'll be able to see changes in where birds are washing up and what species. We can track if birds are dying more because of encounters with offshore wind farms, or perhaps if they're avoiding areas that they used to frequent. Next slide. But we also use these baseline signals to track peaks in mortality where we aren't sure of the cause, and we do this in real time. You can see these red bars appearing in our baseline timeline that are way higher than the yellow heartbeat signal that we would expect year over year. And this particular catastrophic event of Cassin's auklets occurred in late 2014, early 2015. Next slide. And you can see in this map where we have little eyeballs of varying sizes up and down the coastline. The biggest eyeballs were the highest encounter rates in different months of the year, and the smallest eyeballs were tiniest encounter rate signals. We still compared everything to our baseline, but our baseline was blown way out of the water in this mortality event. We saw humongous numbers of birds. Next slide. We're actually worried about this in an ongoing way when we have warmer waters, just like we had just before that Cassin's auklet mortality event in 2014, 2015. We have started to see big die-off events. Next slide. And this is a map of all of those die-off events that our program and partner programs have observed over the years. I'm sorry, I think 3 more clicks for an animated slide. Perfect, thank you. You can see that there has been a little bit of a shift. In the early part of our timeline, we saw fairly small event magnitudes, numbers of birds dying off on beaches. Between 2014 and 2016, we suddenly saw some large events. They were mostly made up of alcids in the lower 48 area. And beyond 2016 up through present, we've seen some variably sized, but pretty impressively large events that are centered on our procelarids and are taking place in the Bering and Chukchi Seas, way up at the northern end of the coast monitoring region. Next slide. Now, we brought together a bunch of different data sets to do this from a number of different citizen science programs. These maps I'm not going to stay on for very long, except to show you the extent of our monitoring program. We would be completely unable to do this without the efforts of citizen science volunteers conducting over 90,000 surveys over the last 30 years to bring these data to you. So we did some modeling based on over 20 years of beach bird monitoring data. Next slide. And we started to look at the occurrence of marine heat wave events, which we defined very specifically for our paper, to see if we saw mortality events to be more likely or larger following a marine heat wave event. This is something we're thinking of not just looking in the past, but also looking forward as we see marine heat waves become larger and longer with climate change. So one of the things that I can pull out of this figure where we're talking about the number of mortality events that are happening post marine heat wave, we're seeing that there are a bunch of mortality events that are more likely to happen either 0 to 120 days after the onset of a marine heat wave event in the ocean, where it's a couple degrees warmer than usual, and also between 180 and 300 days following a marine heat wave onset. So there's sort of peaks following the onset of a marine heat wave where we suddenly start seeing large mortality events happen. I'm going to skip some of the details on this side and say next slide, please. The other thing that we saw when we put together all of our mortality events into the model was that following the onset of a marine heat wave, we did see a bunch of birds dying off. They were unable to survive for a variety of reasons tied to likely foraging and disease, which are tied to increasing temperatures and waters. But we also saw this really interesting pattern where following that huge peak in the encounter rate where we saw a bunch of carcasses on beaches, about 12 to 16 months after that event subsided, we actually saw a depression in the number of carcasses we were encountering on surveys. So there was a rebalancing occurring in the system. Next slide. Here's some really high-level summaries from the other pieces of the model that we put together. Because we're seeing comparatively larger events in recent years where there are more marine heat waves, and those are biased towards specific species groups that we're concerned about, we're really trying to look into this and see if we can do any predictive modeling on how climate might be impacting future mortality events. One of the things we pulled out was that there's a correlation between the event magnitude, the number of birds that die off, with just a small change in sea surface temperature in the ocean. So with just 0.5 degrees change in sea surface temperature anomaly, we saw a 5-step increase in the event magnitude that we were calculating. And we also are thinking about common mortality events responding to marine heat waves with both a peak and then a depression in the number of birds that are washing up. Excess mortality followed by a system reset. One more slide, I think. There we go. All right, so some of the implications of this is that warming oceans with marine heat waves intensifying will lead to an overall shift in ecosystem structure when seabirds are and the marine ecosystem is no longer given time to recover from that peak in mortality rate. With that depression, if marine heat waves happen over and over with regularity overlapping, that time to recover will not be possible. We're looking at potentially lower carrying capacity of some marine birds in the North Pacific if that's true, particularly in the species groups that we've seen dying off in greater numbers more recently with these marine heat waves. And breaking news I wanted to share, we are looking at that El Nino event and warm waters happening right now offshore. We were anticipating some sort of increased mortality event happening at this time of year and also this coming summer. And we are right now seeing reports of cass and sauklets washing in off of northern Oregon and southern Washington beaches. So we're seeing little glimpses already of these models, these predictions potentially coming true. I think there's one more slide that has contact info, and that's all. Thank you so much.
Fantastic, Jackie. Really cool work. And one would have never known that you had a cold, so you survived it well. But this is a really great example of how citizen science can be mobilized to collect some really cool data. We are about to enter into a break, and so we do have some time for some questions here for Jackie. Not seeing any right now, so I'll immediately jump in. You mentioned after a huge mortality event like that associated with the blob, that you then tend to see, I think, what you called a rebound, where the mortality rates are not as high as they normally are afterwards. Is that because essentially all the birds that would have died during that period died during that higher mortality rate because they were somehow stressed and predisposed to dying?
Yeah, we have a couple of theories about that. One is that some of the birds that may have come towards our coastline and bred there and then subsequently died there, maybe in a post-breeding mortality normal signal, didn't return to colony to breed in those following years. So they weren't in the right place for us to have seen that mortality. And one of the other theories is, just as you said, those birds that maybe were the most stressed, the most sick, were the ones that succumbed during that mortality event. So the ones that were a little bit healthier, maybe a little bit younger and just coming up in the world and now able to breathe, were the ones who were left behind in those subsequent years. So we weren't seeing as many dying. So there's always geographic space questions. Birds could be dying that we can't see because they're doing it further away for some reasons, or possibly we just have more healthy birds left over. And we have seen some really good evidence on breeding colonies of what happens following a mortality event, how some of those burrows, for example, are filled in by birds that would normally have been excluded, but this year there's space for them. So the breeding season is actually not depressed in following years.
Great. Do we have any other further questions for Jackie? Okay. Well, I would just suggest that if anybody wants to help out on COASST, I'm sure you guys are always looking for volunteers, and
Absolutely.
it is a great excuse to walk the beach and find dead birds, which are surprisingly cool.
Could be cool. Yeah.